Okay, welcome. I'm Henrik Warne, and I'm going to talk about why automated tests are not enough. I'll just do briefly about my background so you have a sense of where I come from. Currently, I'm a principal software engineer at Nasdaq here in Stockholm. In the past, I worked at Treoptima, Simsoft, Tilgin, and Ericsson. I speak only for myself. What I mean by that is that this is not like the official way of testing at Nasdaq or Treoptima. These are ways that I've discovered that I think work really well and that I've been using, but it's not official from any company. I've been programming for more than 25 years now. I still love to code. I code every day. I think it's a great job. Currently, I am working in Java and Erlang. In the past, I've been coding in Python, C++, and Plex, which is a proprietary Ericsson language. I blog at henrikwarne.com, and I'm on Twitter at Henrik Warne. Right, so the structure of the talk is that first I'll explain a little bit why I'm talking about this, what I mean by automatic tests are not enough. Then I'll talk a little bit about how I typically test when I develop a feature. And then I'll talk in general about manual or exploratory testing. Like there is a bit of the terminology has changed a bit, so I use manual and exploratory testing interchangeably. And then I'll get into some, the way I see it, philosophical reasons why we need more than automatic tests. And then I'll give several examples that have happened to me when I wrote all the automatic tests I thought were necessary, and then I still found problems when I manually tested it afterwards. And then in the end, I'll talk a little bit about testing in production as well, and questions at the end. So it's quite a common claim, I think, these days to say that automatic tests are enough. That's what we need. If all the automatic tests pass, then you deploy it to production. I remember when I heard this is at least 5 years ago, and I heard this, and I just thought, well, that doesn't really, that's not how it works for me. So I started to pay attention to when I discovered problems that the automatic test hadn't caught. And so I collected quite a few of these examples, and I'm basing this talk on those examples. But this doesn't mean that we don't want automation. Like, I am a big proponent of automatic tests. I just don't think that it's enough with them. I think we need a layer of exploratory testing on top of it. But I definitely write a lot of automatic tests, and I think they're really useful. So it's not either or, it's more like both. And the way I see it, when you develop a feature, you write your automatic tests in parallel. But I also think that before you're done with your feature, you need to do some manual testing as well. So it's part of the development process. So it's not part of regression testing. Like it's not something that you should do manually over and over. This is a one-shot thing you do at the end of your feature development. And the result of the manual testing could well be that you add some more automatic tests. So, yeah, like I said before, it's a complement. And almost, like I said, I heard about this more than 5 years ago. Almost immediately, I started to take notes about the cases that I found. So this is collected over several years. So the way I see it, as a developer, I'm responsible for what I develop, what I develop works. So that also means that I test it until I'm convinced that it works, as much as I can convince myself. So and that means using all the options that I have, which includes both the automatic and the manual testing. And typically, I mean, everybody has a production environment. We usually also have a test environment that looks like the production environment, but it's less traffic, maybe not as big, not as much data. And almost everywhere I've been working, I've also been had a local environment, so I could run the complete system on my developer machine, including like having the GUI and a database. It's just that it's scaled down, but it's all the code that's also running in production. And that's really helpful, I think. And for unit testing, I think it's most important for algorithmic code. So where you have to calculate something and you want to test all the boundary conditions and you want to make sure that it calculates the right amount in all the cases. I've seen a really good blog post that divides code into algorithmic code and coordination code. And the coordination code is more like take this and send it there, kind of. You don't do much with it. And for that, I don't think the unit tests give as much. Like it's not that much that can go wrong, basically. And so the effort to write unit tests and maybe mocking things isn't really worth the confidence you gain, because there isn't much to gain in the first place. So the unit tests mostly for the algorithmic code, but then there are more like integration tests where you test bigger parts of the system. So maybe you have like a web server and a database and you make API calls. And I think that is really useful to link together the parts that you've tested with unit tests. And then you almost always get the coordination code tested for free in those cases, because otherwise it wouldn't work at all to run the integration tests. So you have like these islands of unit tests, and then you see that they all fit together the way you intended with the integration tests. But there in the integration test, you don't test all the possible calculation cases, because that's already covered in the unit tests. And then what I typically do when I think I'm done, then I will run the complete system, either in my local environment or in the test environment, and try it out as the customer would see it. You go in through the GUI, say, or you send an API call into the system, but you have like the complete system. It's not just parts like in integration testing. And then I look for anything that looks basically I verify that it behaves the way I think it will behave. And not only do I check that I get the right result, like if I do a calculation, I see that the figures are the correct ones, but I will also look at the logs and see that they say what I expect them to say and nothing else. And also, I mean, obviously, if there are crashes or errors in the logs or anything like that, you need to investigate that. And the exploratory testing is really well described in this book that's called Explore It by Elizabeth Henriksen. I can really recommend it. It's very thin, but it has a lot of good advice on how to do exploratory testing and good heuristics on where you should look and stuff. So really a good read. And in exploratory testing, when we talk about that, there is a very important distinction between checking and exploring. And checking is what we do in automatic tests. That's where you have like an assert that says the result should be 5. That's checking that it does what we have determined it should do. Whereas exploring is much more fluid. You look at the whole system and you look at things to see that everything looks right. And it's sometimes hard to say what exactly are you looking for. But humans are pretty good at detecting things that are out of order, even if you can't put your finger on it sometimes. You can see that that doesn't look right. So that's the difference between checking and exploring. So, like I said, we look for anything out of the ordinary. And another key component of exploratory testing is that you let what you see guide where you go next. So if you see that something looks a bit fishy, was this really correct? Then, of course, you start testing that more intensely. You try out different things and you try to narrow it down. What was it? So you're not just following like a script of what you should test. You decide based on what you're seeing. And I mean, often you don't find anything. Everything works the way you expected. So that's just fine. But sometimes there is something that you need to look into further. And this is a quote from the author of the book. And I'm not sure if she meant automatic test or when you do like scripted manual test, like you have test cases that you follow. But it applies in both cases, I think, that whenever the biggest bugs they always found when they weren't sticking to the fixed test cases, but thought for themselves basically and tried things that they hadn't written down to do. And there's another good analogy, I think, that Nassim Nicholas Taleb writes about in his book Anti-Fragile, which is quite an interesting book, I think. But one thing he talks about is the difference, and this isn't in the context of software development, it's just something that he writes about, which is the difference between a tourist and a flaneur. And the way he sees the difference there is that a tourist has like a fixed agenda. Say if you go to Paris, you know you want to go to like the Eiffel Tower and the Louvre, say. So you go there, you look at that site, and you go to the next site to look at that. Whereas the flaneur is also a visitor in Paris, but that he doesn't have a fixed agenda. Maybe the flaneur thinks, I'll get to the Eiffel Tower, I think, but he starts walking out from his hotel and then kind of walks down the street, and maybe he sees like a market that looks interesting and lots of local people there, like buying fruit and vegetables, say. And so he goes and looks around there, and maybe he gets talking to somebody that sells vegetables, and maybe that guy recommends a new restaurant that his brother is running or something like that. So you kind of you're not fixed in what you're going to do. You kind of you're guided by what you find, and then maybe you discover things that are really interesting, but you would never have found if you just stuck to your fixed agenda. And that's very similar, I think, to how exploratory testing works compared to automatic tests. You kind of discover things that you didn't really know that you needed to look at, so to speak. So when I look back at these examples that I've collected, there are a few things that I've thought motivates why I also need to do manual testing. And one of them is that it's, for me at least, it's quite hard to come up with all the test cases without running the complete program. It's just harder for me to come up with them when I write the automatic test than when I see the complete system. I see it in a different light, basically. So that's one of the reasons I think it's useful to do exploratory testing. Another reason is, like I talked about before, how you do unit testing, and then you have a fairly well-tested piece, and then that fits in with other well-tested pieces in the integration tests. So the integration test is like a step up from the unit test, and then you use the smaller parts, and they're tied together in the bigger part. And I think it works the same way with exploratory testing, but here it's the complete system that's the higher level, and the different integration tests are the chunks of the system, but they're knitted together when you run the whole system. So you get one level up again that you don't get if you just stop at the automatic tests. And then something I also noticed quite a lot is that the automatic tests are very focused on the code, what the code does, which is kind of natural because you're working in the code, and so you want to test what you do works. But when I'm looking at the complete system, I'm more concerned about the system behavior. I'm not thinking about the code so much. I'm just thinking, is this the right thing that should happen? And that's also quite a good reason, I think, for doing these this manual testing at the end. So I'll go through some examples here, and these are all taken from when I worked at Trioptima. And I'll just say a little bit about the system that I worked at there. It's a system that sends margin calls, and margin calls are used when you have like big banks that trade with each other. Then it's these like bilateral trades, and so it's like a zero-sum game. So if one bank is plus $100,000, the other bank is automatically minus $100,000. So depending on how the values move over the days, one or the other bank is on plus and the other bank is on minus. And there is lots of regulation that says that to avoid like economic crisis, the one that's on minus has to transfer the money that they owe to the other party every day, so that you're even at the end of the day. So that if the one that owes money goes bankrupt, then the other party will have got the money that's owed to them. Okay, so every day you can send these margin calls, and the margin call just says, you know, you owe me $75,000. Please send it to me, and then they can say, okay, I'll send this. Is that fine? Yes. So they agree. So that's the process that goes every day. So this is like the scene for all of these examples. And this is based on notes that I took for about 3 years. And I got 21 examples, so 7 per year, like roughly every other month. Not all of them are so easy to explain, so I picked the ones that I can like reasonably explain. And very often it comes down to assumptions about the system that weren't true in one way or the other. And it also helped a few times that I had like dirty test data, which is basically when I run my system locally, you'll configure something and test something, and then you kind of leave the configuration there, and then you configure something else and test, and so you end up with a bit of data. And sometimes it's, you know, you've changed some things, and so there is a bit of data left over, and that's a good thing sometimes, because you get effects that you wouldn't normally see in automatic tests, because there you typically just you set up the test by setting up exactly the data you want, nothing more, nothing less. And so there is rarely the chance of getting these surprising data settings that help you discover things. So that's another thing that helps, I think. I mean, the dirty test data, you have that in the test system as well. So for the first example, it's about something that should not happen. And when you are sending these margin calls every day or at midnight, basically, you set up the position that you're going to use for the day. And in there, it's just a holder for the data that you need to calculate if you owe money or if you should send out a margin call. And so you get the figures and you can calculate, should I send out a margin call or not? And if you send out a margin call, then you don't want to change any of the data that the call is based on, because you've figured something out that you want money from them. You can't change what the calculations are based on. So once you've sent out the call, you lock it so you can't change any data. And we discovered kind of early on that if we had set the wrong currency, I mean, we didn't allow it to be changed at all. But then we realized that if you change it before you send out the margin call, then it's okay, because it's only when you send out the margin call that it's a problem if you change any data. So we said, okay, we're going to allow you to change the currency before the call is sent out. So I made that change. Yeah, I said that. So I made that change. I allowed to change the currency before you send out the call. But what I didn't think about, and what happened, was that another part of this data holder, the type of the call, got cleared. It got set to none. And I didn't think about this when I wrote the test for it. I just asserted that I could change the currency before, but I couldn't change the currency once the call was sent. But I didn't notice that the type of the call got changed or got cleared to none until I ran it on my local system and saw it in the GUI that, okay, I changed the currency, but this value here just got cleared. And that's, yeah, and it's very obvious when you look in the GUI, but it's not at all obvious when you assert on it. And the problem here is that it's hard to assert for everything that shouldn't change. Like it's basically a lot of more things that should stay the same. And I didn't have any assert for that. And it's kind of basically hard to assert on all the things that should stay the same. But when I ran the system, it was really obvious right away. So for the next example, it's a case of strings versus floats. In the back end, we used floats. So I wrote a lot of tests. This was for changing, like making sure you couldn't send a margin call with inconsistent values, basically. And so I wrote a lot of test cases to test that all these things were blocked in the right cases and allowed in the other cases. But when I ran the complete system, I realized that from the GUI, even though it was figures, they were actually sent in as strings. And that was for historical reasons, but it was something that just was that way. And then there was, in addition to that, there was a conversion problem. So that caused the calculations to not be correct because of the conversion wasn't done correctly. And that's another thing that I didn't, I thought I had really good automatic tests for it, but when I saw it in the complete system, it was another thing. The third case, there we had the data that comes into the position that we base the call on. It could be like a list of trades, and then you should sum the values of the trades so you know the total value. And we both had the actual trades and we had the sum of the trades. And here is another case where at first we allowed that to be changed and then we wanted to stop it to be changed. And so after the call is sent, we don't want to allow changing any of the trades. But we still allowed this, what I call the pre-calculated sum, we still allowed that to change because that wasn't part of the call. It was just for information. But before, they were always changed in tandem. So you changed any of the trades, you also changed the pre-calculated sum. But when I stopped the possibility of changing the trades, I didn't think about the pre-calculated sum. So that one could still be changed. And what happened was that in the GUI, we had relied on this. We just said, the sum of the trades and the pre-calculated value, they're always the same. So we're just going to display the pre-calculated value. But after that changed and the trades remained the same, they were out of sync. And that was, again, something that was easy to see when I did it in the complete system. But when I made the automatic test for this case, I wasn't aware of this use of the sum in another context. And that's something which I call like an implicit dependency. Like it's not so obvious from the code, but it's used because they had the same value before. And that's, again, something that you can clearly see when you use the system. Another thing was when I updated something in the GUI, the way the front end works in this case was that it sends all the values. And some values are changed, but there are lots of values that are unchanged, but all the values get sent. But there's another way. We can also use APIs to do the same thing, like the GUI just uses the API, but you can use the API separately. And when you use the API separately, you only need to send in values that you want to change. You don't need to send in all the existing values. You just send one value if that's all that's changing. And when I wrote my automatic tests, I just did the API case. I wasn't really thinking about how the GUI was working. So I just assumed that if a value wasn't changed, it would be missing. But that wasn't the case when it came from the GUI. Then there were values sent in, but they were the same as the existing ones. And that caused an error. So basically I had to rewrite that. And this is like a case where after doing like exploratory testing, I realized something is wrong, and then I add or rewrite the automatic tests. And in this case, I had to change like the whole implementation to make it work in both cases, both for the API case and the GUI case. And the final example is it's not exactly exploratory testing, but it's still an interesting case, I think. And here it's when we were fetching FX rates, like foreign exchange, like basically the conversion between different currencies. So it's very important to get the rates for every day so that you can calculate the margin calls in different currencies. And there is a provider called Refinitiv that we were fetching the FX rates from. And they changed their API, so we had to update our code. And the way their API works, and I mean, this is what we had to work with. You can't ask for a date. You just say, give me your current values, and then they'll send back like the rate for like dollars and euros and Swedish krona. And they'll say, this is valid for this date. And then you ask again, and then they'll say the date. And eventually you'll get the next day. So it would have been good to be able to ask for a specific date, but that's not how the API worked. So we basically queried every hour and then stored it when we got a new date. And we wrote lots of automatic tests for this case. But the problem was that when the date changed, say now it's like the 4th of May. So when it turns over to the 5th of May, then we would send out what's your current rates. But we would get back the rates for the 4th of May for a few hours before it switched to the 5th of May. And we had assumed that we would get the 5th straight away. And so, but this didn't cause a big problem because our logic basically did this. Here are the values. And we would see we're missing the rates for the 5th of May. And here are the values. These are for the 4th of May. Okay, we'll write them down for the 4th of May. So what happened basically was that we wrote the same value a few times. We already had the 4th of May, but we kept asking because we thought we were asking for the 5th of May. So after a few hours, we got for the 5th of May, and that's fine. We wrote for the 5th of May. So it didn't really cause a big problem. But, yeah, not terrible, but wrong. But when we ran this in our test system, we looked at the logs, and we saw that we were writing the same thing several times, and we thought we would only write every date once. So we started to investigate, and then we realized that the way this API works is not the way we thought it worked. And this is another case, I think, where like it's a faulty assumption, and if you have faulty assumptions, like you can write really good tests, but they're testing for the wrong thing, and that's what happened here. But fortunately, we looked at the logs, and we saw this strange behavior, and that's kind of like how you do in exploratory testing. You see something strange, you start to investigate, and it didn't take long to figure this out, and then we could update our automatic test for this case too. So yes, we misunderstood how the API worked. So the lessons from these examples and from the other ones that I haven't talked about is that it's a lot easier to see these missing cases when you have a complete system than if you just have your test case. And many, or yeah, almost all basically, problems are from assumptions that aren't true, either about the behavior or the data. And sometimes you don't get exposed to these assumptions because you're not running the complete system, so you don't see how it all fits together. And also the case of implicit dependencies, like the sum of the trades, the pre-calculated value versus summing them. Sometimes you have these things and you're looking at too small of a part when you just look at a test case. If you see the complete system, you see more of these dependencies that exist that you don't see when you just run your specific automatic test. And exploring, I think it's, at least for me, it's a lot easier to come up with additional test cases as well. It's just, you think about different cases because you have more of the complete picture in front of you. So it's easier to try different things. And then, so, I mean, you could say, well, maybe I'm just bad at writing automatic tests. I should have come up with these test cases before, because all of these things could be tested with automatic test cases. But it's the same. If you argue that way, you can equally well say, why are there bugs at all? You should have just written the correct code in the beginning. Like, there shouldn't be any bugs if you do it correctly. But that's not how it works. And for me, it's hard to come up with a really good, complete set of automatic tests. So that's why I think it's valuable to do these, the manual testing as well. Right, so just a few words about testing in production, which is a related topic, I think. Many developers, I think, are kind of end when they deploy something to production. So now it's deployed, now I go and do the next thing. But I think it's very useful to deploy it and then look at the logs a little bit and look at if things behave the way you thought they would behave. Typically, I will have, you log for normal cases and you log for abnormal cases. And typically, if I deployed something, I would start looking at the logs a bit and see, and then I would remove the log statements that are the ones that I expect to happen, and then see, is there anything else if I remove these expected ones? And often something weird will turn up, and then you have to start investigating, why did I get this? I thought I would never get this case. And that's been many times that I've gone several loops over this and found things that I didn't think would happen, and then you deploy something new and you find other things you didn't think would happen. And I mean, especially, it's hard for the test system to have enough data to cover all the weird cases. So that's why I think it's important to check the logs of what you've deployed to make sure it behaves the way you think. Also, and I think most people maybe do this, but to have test accounts in production so that you can test in the correct environment. I mean, you want to test as much as you can in the test system and your local system, but it's really good to be able to do operations in the actual system as well and see what happens. Feature flags as well, so that you can enable a new feature for only one customer, say, so that you can let them test it without everybody else getting the feature at the same time. Gradual rollout is something we did a lot at Optima as well. So we would take the first letter of the party group, and if it was A to D, then they get the new feature, and otherwise not, and then we would increase it. And also, I think to save yourself some trouble is to be able to enable and disable new features, so that you can just turn it off if it's a problem, so you don't have to roll everything back. Just disable the feature, and then you have time to investigate. Sometimes too, which it's really useful when it happens, but it's not so often, but if you change an implementation, if you keep the old implementation, you have the new one in parallel, you can both compare the results between them, and you can also, if anything goes wrong in the new way of doing it, you just fall back to using the old way, and then it's not worse than it was before. So these are some of the techniques that we used at Optima that I thought were really useful when you've moved into production with a feature. So to recap, automatic tests are good. I'm not against automatic tests. We should have as many as we think are useful, so we convince ourselves that it works, and for regression testing. But the manual testing finds additional bugs, at least that's my experience. So I think it's something that it doesn't take a lot of time either. Like it can be done in 10 minutes maybe if it's a small feature. It just depends. But often I did find stuff. So I think it's something that it's a shame to skip that step. And keep looking in production as well after things have been deployed, and try things in production as well. Yes, that's it. Any questions? Yeah.
When you do the manual exploratory testing and find things,
yeah.
do you automatically add those to the automatic tests as well?
Sometimes, but sometimes when I find something in manual testing, do I automatically add them to the test suite of automatic tests? Not always, actually. Sometimes, like in the case where I had to even rewrite the whole feature to cover both cases, then for sure. And sometimes I will add things, but not always. But mostly, I would say it expands the test cases, the automatic tests. Yeah. Yeah. Is it possible to do the exploratory test without a GUI? Yes, definitely. In our case, we did have a GUI. I mean, some systems don't have a GUI at all. But in our system, we have a GUI, but we also had API access to everything you could do from the GUI. And many features that I developed would be to do with a feed. We had a feed of data from another system into the positions that we used for the margin calls. And there's only API access. But I still did basically the same thing. It's just that I did API calls with weird values, and I would send them in. So I did that even with when it's only APIs. But many of these examples, I mean, it's quite obvious in a GUI sometimes when things change. You have to work a bit harder when you use the API. So I did it in both cases, but many things stand out more in the GUI case. Yeah.
Do you consider yourself as a tester or a coder?
Yes.
Because in my
Yeah.
organization there is a very big gap
Okay.
between those roles.
Yes. Do I consider myself a tester or a coder? And the way I see it, and he says also that in his organization there's thick walls between coders and testers. But the way I see it, I mean, I say I'm a developer, I'm a coder, but I'm interested in testing. But I also think of it as when I develop something, it's my responsibility to deliver something that works. And so I think it's my responsibility to test it as much as I can so that I am confident that it works the way I want it to work. We also had people that tested some features after the developers were done. It was like product managers that also tested. And so it doesn't stop you from having dedicated testers, I think. But for my own peace of mind, I want to make sure it works the way I think it works, the way I think it should work. So that's why I do testing myself, even the manual testing. Yeah. Yeah.
Was there a reason why you started taking notes for all the tests?
Was there a reason why I started taking notes for all the tests? Yes. It's actually, I've given another talk, even here at Jfokus actually, that's called Learning from Your Bugs. And that's something I've been doing for almost 20 years now. And it's, if I come across like a tricky bug, I will write down some notes of it so that I remember it and so I can learn from it. And so I already had this system in place. And when I heard about people saying, you know, if all the automatic tests pass, it should go into production, and I wanted to know if I came across these cases, then I just thought I'll just use the same system. So anytime this happens, I'll just write down some notes. And it's not much. It's like, 10 lines at the most about what happened. And so I already had that system in place. And I used that to write these down so that I could see, I mean, if I could find some trends in it. So that's why I started doing that. No more questions? I'll be around on the conference, and you can ask questions afterwards as well if you want. Okay, thank you.